Hello everyone, I'm Yu Chen, the author of PGC. Now I'm going to make a demo of our PGC system. Please excuse me of my lousy English and just focus on the demo. In this demo, I will show 5 test cases. So from now on, we will use M1 to denote Alice's initial balance and M2 denote Bob's initial balance. V1 denotes the out transfer amount and V2 denotes the in transfer amount. By default, V1 should equal to V2. And V1 prime denotes the amount claimed by Alice, and V2 prime denotes the amount claimed by Bob. We say a confidential transaction is valid if the following conditions hold simultaneously. That is, V1 should equal to V2 and V1 should lie in the right interval, and M1 minus V1 should also lie in the right interval. That means Alice have enough money to spend. Okay, we will begin with the first test cases, which is a valid confidential transaction, and both Alice and Bob correctly testify it. Okay, let's choose the code. Uh-huh. Okay. This is the directory of our source code, which is written by C++. So the code could be further improved with to obtain better performance. So let's compile the demo. Okay, let's compile it. And execute the demo. Okay, in the first cases, we will set the initial balance of Alice to be 512 and the initial balance of Bob to be 256. Set the out transfer amount to be 128, and also the same is the in transfer amount 128. Both Alice and Bob claimed the transfer amount should be 128. Okay, let's do the confidential transaction. Look here, Alice and Bob's account have been created, and here is the process of confidential transaction generation. First, set the nonce and then generate the basic confidential transaction information, and followed by a proof of its validity. Here is how long the confidential transaction generation takes and its size. Here is how the consensus protocol checking the validity of a confidential transaction. It will check if the plaintext equality proof is correct, if the range proof for the right interval is correct, if the range proof for enough balance is correct, and finally, if the ECDSA signature is correct. If all these conditions hold, we say this confidential transaction is valid, and it will be posted on the chain, and both Alice and Bob's balance will be updated. Look, if there is a dispute, both Alice and Bob can generate proof for the confidential transaction transfer amount is indeed some value. Here, both Alice and Bob can succeed to justify the computational transaction. Indeed, encrypt the transfer amount to 128. Okay. Now let's show the second test cases, which is an invalid computational transaction. It is invalid because the out transfer amount differs from the in transfer amount. The consequence is the plaintext equality proof will be rejected. Okay, let's see it. Okay, the initial balance of Alice is 512. The initial balance of Bob is 256. We set the out transfer amount is 127, while the in transfer amount is 128. Clearly, this is invalid because the out transfer amount is less than the in transfer amount. Okay. Both Alice and Bob claimed the transfer amount is 128. Okay. Look, the plaintext equality proof got rejected, so this confidential transaction was thought to be invalid and will be discarded. Okay. Now let's choose the third test cases. We say it is invalid because the out transfer amount does not lie in the right interval. The consequence is that the range proof, the first range proof for the right interval will be rejected. Okay. Now the Alice initial balance is a very, very huge number, which is 2 to 64 minus 2. Okay. The initial balance of Bob is 1, 2, 3, 4, 5. The out transfer amount is 2 to 64 plus 1, and also the in transfer amount. Sorry. Both Alice and Bob claim the transfer amount should be this value. Okay. The consequence, as we said, the consequence is that the range proof, the first range proof for right interval is not correct. Look, the first range proof for right interval got rejected. Let's move to the first cases, which is also invalid confidential transaction because M1 minus V1 does not lie in the right interval. The consequence is that the range proof for enough balance will be rejected. Okay. The initial balance of Alice is still 512. The initial balance of Bob is 256. The out transfer amount is 513 and the in-transfer amount is 513. Both Alice and Bob claimed the transfer amount is 513. Look, here, the initial balance of Alice is 512, which is less than the claimed transfer amount, 513. So the consequence is that the confidential transaction will be rejected because Alice does not have enough balance to make this transaction. Let's see the code. Look, here the second range proof for enough balance got rejected. Now let's show the last cases. In these cases, Bob received a confidential transaction in which the transfer amount should be 512, but Bob tried to claim that it only encrypts 511. So clearly, Bob fails to justify it because it's wrong. That is, V2 differs from V2 prime. The consequence is that Bob's account proof will be rejected. Okay. The initial balance of Alice is 512. Initial balance of Bob is 256. The auto transfer amount is 512. The in-transfer amount is 512. The transfer amount claimed by Alice is 512, and the amount claimed by Bob is only 511. So Bob's justification should be wrong. Let's see it. Okay, this is a valid confidential transaction, of course. But Bob failed to justify this confidential transaction encrypts the transfer amount 511 because it should be 512. Okay, that's all. Thanks for watching. Bye bye.